So this is section 3.2. And the title is Graphs of Functions. Okay, so if you take a look at the pink study guide that I passed out in class, we're just going to follow along with the study guide. So we are going to start with a basic definition. Up at the top of the page it says the blank of a function. So we are going to talk about the graph of a function. So the graph of a function in the variables x and y is the set of points x, y in the Cartesian plane that satisfy that equation. So basically what we want to keep in mind now is the relationship between the algebraic definition of a function and what that looks like in terms of the graph. So now every xy point on the graph of some function, so let's say this is just y equals f of x, so every xy point can now be thought of as x f of x. And that's a really important relationship to understand. So that means that I can think of a point, if I was looking at the point when x equals 1, so let's say that's 1, then that point would be 1 f of 1. If I was considering the point when x was 2, so this point would be 2 f of 2, and the way you can find that y value is by plugging 2 in for x in that f of x definition. So for example, if we look at letter A, it says, is the point 1/1/3 on the graph of x, or on the graph of f? And f of x is given to us as x minus 2 over x minus 3. Okay, so how do you know if this point lays on that graph? Well, remember, every point on that graph is x f of x. So if I want to know if this point 1/1/3 lies on this graph, then I need to sub 1 in for x and see if f of x is equal to 1/3. So basically I'm looking for 1 f of 1. So what happens when I plug 1 in for x? We get 1 minus 2 over 1 minus 3, which will give me a negative 1 over a negative 2, which is positive 1/2. So positive 1/2 is not 1/3. So the answer is no. The point 1/1/3 is not on the graph. And since we got 1/2 when we plugged 1 in for x, what point would be on the graph? Well, we just found out when x equals 1, f of x is 1/2. So that would be the point that is on the graph of this function. Okay, let's take a look at letter B. So letter B says, if x equals 3, what is f of x? Okay, so it's the same thing. I want to find that point when x equals 3, what is f of x? So again, we are told that f of x, we're using that same function, is x minus 2 over x minus 3. So now if I plug 3 in for x, I have 3 minus 2 over 3 minus 3. So 3 minus 2 equals 1, and 3 minus 3 equals 0. So what does that mean? That means that f of x is undefined. When x equals 3. And in fact, we knew that already, because if I consider the domain for this function, we know we can't have a 0 in the denominator, and what value would give me a 0 in the denominator? 3 would. So when x equals 3, what is f of x? F of x is undefined. So what point is on the graph of x, or f of x? the answer would be there is no point. Okay, so now x and y intercepts. We've already talked about this, so this should be review. Remember, any x-intercept is x comma 0. So we're looking for that x value. X-intercepts always have a y value of 0. And likewise, when I'm looking for a y-intercept, I have a 0 for x. So that's exactly how I find them. I plug 0 in for y to find the x-intercept, and I plug 0 in for x to find the y-intercept. So again, going back to that definition, x minus 2 over x minus 3. So if I put 0 in for x, I will have 0. Oh, I just said that backwards. That would be finding my y. To find the x-intercept, I plug 0 in for y, which is f of x. So this would be 0 is equal to x minus 2 over x minus 3. Let me give myself a little bit more space. So now, how do I solve this? We have to recall what we've already talked about. This is a rational equation. So I'm going to multiply both sides by the denominator. So when I do that, we'll cancel on the right. So I have x minus 2. And on the left, 0 times anything is 0. So I'm just solving x minus 2 equals 0. So if I add 2 to both sides, x is equal to 2, which gives me an x-intercept 2 comma 0. So now let's do the same thing over here. This time we're going to put 0 in for x and find y. So remember, y is f of x, so that's what I'm looking for. And I'll have 0 minus 2 over 0 minus 3. Or 0 minus 2 is negative 2, 0 minus 3 is negative 3, so that gives me 2/3, and a y-intercept of 0 comma 2/3. So I have two intercepts, 2 comma 0 and 0 comma 2/3. Okay, so I'm going to stop this one here and we'll look at 2 examples on the next video.